Welcome to Made in Science, the official podcast of the University of Stuttgart. Professor Michael Totzeck is with us today. He works as Innovation Manager and Fellow in the area of Corporate Research and Development at Zeiss. He is involved in many projects, identifying technologies, searching for trends, and evaluating them also for Zeiss. At the company, he improves products and recognizes areas in which new products should be developed. Professor Totzeck's current scientific interests are quantum technology, artificial intelligence, and additive manufacturing. Moreover, he is also on the Scientific Advisory Board at the Institute for Quantum Science and Technology. In our conversation, we will hear about new organizational structures at companies, define evolution in a new way, and learn why working with pencil, paper, and an idea is still a most promising approach at our times. Professor Totzeck, it's great to have you here with us today. Thank you indeed for having come to Stuttgart.
Thank you for having me.
At Zeiss, you are working as Innovation Manager and Fellow. Can you please explain what the Fellow position is defined at the company?
At Zeiss, we have two kinds of careers. One career is, let's say, the normal disciplinary career. So you become responsible for more and more people. There's a second career path that is called the expert ladder. That is tailored for experts who want to become responsible in a way for more and more technologies, for more and more fields. And in this expert ladder, we have 5 steps. So from a senior to a staff to a principal scientist, senior principal, and fellow. So the fellow is the highest rank in the expert ladder of Zeiss.
You say, quote, "The motivation for my work comes naturally. I simply want to understand the impact that technological progress has on our lives and help shape it, of course," unquote. Now, technological progress, as I just mentioned, and the interests you have, focus on AI, autonomous driving, changes at factories, Industry 4.0. These are quite a lot of topics. Which one do you work in particular? Is there anyone that you favor? Anyone that is currently very, very much taking up a lot of time for you?
So first of all, why is it so broad? Let's say the technologies outside, they impact a company like Zeiss very strongly. So new products are defined currently by different technologies. In the past, it was hardware. Now, for instance, it's the software. And it is the evaluation of data with artificial intelligence. So first of all, it's necessary to keep the breadth, the width of the topics. And then, of course, I focus on certain topics that are in particular promising. Most promising, I think, is artificial intelligence currently, which has a huge impact on how optics will be done in the future. Software at a whole, digitalization is also very important. Artificial intelligence is a kind of an additional step in this software centricity of the evaluations. Other fields like, for instance, additive manufacturing, I followed a lot. We had brought out a product that looked here for quality assurance in the field of additive manufacturing. So it's this quantum technology. I put a lot of personal effort in order to tailor and evaluate how important that field is going to become. Because there have been a lot of promises on quantum computing, for instance, quantum communication and sensing. And one of my duties and tasks is to see clearly what will be in for a company in the future in these fields in terms of threats and opportunities. So quantum is eating up a lot of my time as well.
You mentioned promising and promise just recently. I have to follow up on that. I'm interested, what do you mean? How do you actually define what categories, what aspects that you work with when it comes to suggest something as promising or to call something promising?
Yeah, that is a very good point, because the question, so what actually do we mean when we say a technology is promising? And there is quite a difference to the interpretation you have at university level. So for us, a promising technology is a technology that has a promise to become a real innovation. Innovation means that it has an impact on the market. It means that we have a product that changes the way how things are done. For instance, that's why artificial intelligence, and for instance, consider ChatGPT, is really changing the way how are we searching in the internet. Digital microscopy is changing the way how microscopes are actually working. So that's an innovation. And we have to distinguish from that the invention. That is, if we have an idea and we find a cool new concept or principle, and if you publish this, for instance, and in a paper, if it goes very well, you do this in Nature or in Science, and you find a broad interest. But nevertheless, you don't know whether this is really going to become an innovation. For that, you have to consider the customer. So some people called customer have to use it, and they have to be willing to pay for it. Otherwise, unfortunately, for a company, that is not very useful, because we have to earn the money that we use then further on for further innovations.
You just mentioned AI and also ChatGPT. I wonder, I read this morning, actually, an article where the statement was made that ChatGPT is not artificial intelligence. It uses linguistics, it uses statistics to come up with texts, basically, what I understood from that. How do you see that matter?
I think we should differentiate. So artificial intelligence as a single word maybe is just too broad. We have weak artificial intelligence and what we call general artificial intelligence. With general artificial intelligence, we are in the field of what human beings can do. Weak artificial intelligence is something that relies, for instance, on statistics, as ChatGPT does. So far, what we see, in my opinion, is really only weak artificial intelligence. We have the issue that we don't really understand how to put trust in what we get as a result out of the artificial intelligence. That is a huge research field. And so far, in my opinion, we are far away from a general intelligence like human beings have it.
Thank you for clarifying that for me and all of us. Let's talk about the structure of an enterprise. I know that the structure of an organization and also of an enterprise, the horizontal and vertical line system is something applied these days quite often. I understand also from my colleagues abroad that universities have implemented this structure as well, not only companies. In your mind, what does the horizontal/vertical line system mean, and what are some of its disadvantages and perhaps advantages?
So this is called usually a matrix structure. So as in a matrix, you have columns and you have lines. So what you mean, I believe, is the horizontal and the vertical lines here. So in a matrix structure, you have very often competencies distinguished from applications. So for instance, we have people who are experts in optical design, in software, in system engineering, in electronics, all the different fields and competencies you need to build an actual product. And then, of course, we have different products. We have surgical microscopes, we have lithography optics, we have, even in these fields, we have, again, different kinds of products, different variants. And in such a matrix organization, the realization of such a product is in a way distinguished from the fostering and the development of the competencies. So the product searches actually the right people from the different competencies. They build a project group and then they realize the project. If you don't do that, what you can do, of course, is that your internal structure is immediately derived from your product structure. Now, in my opinion, that works if I have a very limited amount of products. If I have a large amount of products, I need to develop the competencies further. For instance, an interesting aspect is the competence development and optical design. We need optical design. Zeiss is an optical company, optoelectronic company to be more precise, and optical design is a core technology. And every product, most of our products, honestly not every, but almost every product needs actually optical design. Now consider that you have a single optical designer sitting in a department here doing this product development and having no contact whatsoever to the other optical designer. He's a kind of a Highlander working for himself or herself, never able to really develop, never able to see what others have done, to learn from other people. So it makes sense to pool this kind of competencies. And we try this, so we have incorporate research and technology, a huge pool, for instance, of optical design. By the way, also a huge pool on artificial intelligence. And these people develop the technologies for us. They educate each other. They have different formats for this. They reach out. So they are developing the technology in order to provide the best technologies for the product requests that come over time.
You said in one of your interviews that I read, and I quote again, "I celebrate the success of Zeiss, but when it doesn't work, I also suffer," unquote. What does suffering mean here? What does success mean for you? And how do you live in your team, perhaps, also, these principles?
So let's start with what is success, what is, let's say, failure or non-success. So in corporate research and technology, success is if one of our technologies really makes it into a product. Success is if a product finally, of course, makes it really to a launch. So from a development point of view, we are creating opportunities for the company. And then other people, for instance, here from product management, have to decide whether this is valuable enough to really be put into a product. If you do this kind of development, every now and then, it just fails. You have, for instance, miscalculated something. You haven't seen a severe hurdle in the development. You have underestimated certain difficulties and problems that come up. And then all of a sudden you see, hey, I thought this technology is very important and very useful. Unfortunately, it is not. We have made an error. And for me, again, success is if we bring this to the market, and failure is if we discover such an error and say, hey, it doesn't work. However, what you have to realize is that if you do cutting edge research and development, then you must fail sometimes in between. If you don't fail, if 100% of your developments are successful, then your aspiration is just not high enough. You don't dare to go to the borderline of what is possible. But for instance, in EUV lithography, that is only possible to realize if you go to this borderline as close as possible. It's like in a racing car, for instance. The ones who win are the ones who really use their capabilities to bring the car to the absolute border of what is technically possible. And we try to do this with technologies as well in a corporate research and technology. And every now and then, of course, this fails. Yeah, and then if it fails, then failure culture back and forth. I'm just not happy. If it fails, so sorry, I'm sad, sometimes angry if it is due to me. If I say, hey, 2 years ago, I could have really detected this already, but I didn't. Then it is really just a huge learning for me, and it's also a kind of a failure, and then you suffer. But I believe if you're a real fan, then of course you just don't celebrate the successes. Suffering is really part of it. I think a real soccer fan of a soccer team is not only celebrating the successes of his or her team, but also not celebrating, but suffering the failures. So if you're really with something, suffering, unfortunately, is part of it as well.
Is that what you call, in one of the Zeiss story segments online, the evolution that happens? You have to be daring, you have to be enduring in a very tough environment sometimes as well. And is this a strategic approach at Zeiss to push the limits and that in that particular fashion, the company then manages to explore fields unknown?
Yeah, our tagline is pushing the limits of imagination. So we try, of course, as a company, we do not always succeed, but we succeed quite often in really going beyond what is thought as being possible as of today. So optical lithography lives from pushing the limits. Super resolution microscopy is clearly pushing the limits of what can be done in terms of imaging. So and in the medical field as well, you try to be as, let's say, as good as partner as possible for the surgeon, so that less errors happen, that the surgeon, for instance, knows what's beneath the tissue that he's going to cut into. So you try to help the people, and for that you need to push the limits of technology very, very far. But of course, it depends on the technology, how far you can push it. So, and then we come back to the role here of a fellow. You need to identify the right technologies. Some technologies can be pushed very far. Some other technologies might be as promising as they are from the onset, can't be pushed because it's not possible to do it.
That may be the technological side that you refer to. On the other side, at the other end, no, that may not be the word really, but you should perhaps or could also consider the ethical questions that comes with innovation. And how is that done in your field of work?
It is fortunately not very difficult because the markets we are in, there the ethical component is very important. So if you are in the medical field, it's all about healing people. And that has no issue in terms of ethics. From an ethical point of view as well, Zeiss is owned by a foundation. The target of the foundation is to foster science and technology and education in the states where Zeiss is present. And that is also something that resonates with me very well in terms of ethics. Of course, if you are developing technologies, for instance, like digitalization, and Zeiss is instrumental in realizing the chips of the latest generation, for instance, then it is, as always, you can use it for good and for bad. There it is very difficult to distinguish. But we believe that digitalization is necessary by any means. So we also bring this further on and bring this forward. And by the way, if it comes to sustainability, that is also a topic that is currently a big one that we follow. We have an initiative that is really following sustainability and is now implemented really in all the business units. So sustainability is also a part of our thinking and a part of our development.
As we have heard, you are on the board, on the Scientific Advisory Board at the Institute for Quantum Science and Technology here at our university. What does this particular role imply? You just mentioned that education is also very important for Zeiss and that particular area. What tasks come along with your role as an advisor in that board? And perhaps also, what changes could you already implement in via this board, also at our university?
So my role in this advisory board and in other advisory board I'm in is usually the industrial perspective. So the people there asked me to be in it in order to represent the connection to industry. So what does this technology finally mean for industry? For Zeiss somewhat in particular, but in such an advisory board, it's more that you as a member stand here then for a broader field of different industries. And there is just to bring in the industrial perspective and to see where are developments promising, as we had it at the very beginning, from an industrial point of view, and where are developments just less promising. And promising here, again, we have discussed what it means, but in terms of action for the IQST is a question, is this already a technology, for instance, that they have developed a certain kind of a quantum sensor? Is this now a technology that should be developed in the conventional way in an industry, just optimized in order to make it a product? Or does it need, as in my opinion, for instance, the quantum computer, again, severe science, really scientific breakthroughs? And here, I just bring in the perspective. So such an advisory board is really a group of people, and they try to come to a consensus of all the different voices that are there with their different backgrounds. And we try to find some kind of consensus and recommendation then for the IQST. And that can be beyond science, by the way, also in terms of organization, because in a company, you know a lot about different organizational modi, so how you can do things like that. And there, of course, if it can be applied, I also bring in the advice, just from my background that I have. I've seen a lot of different organizational, structures inside a company. And I have at least a rough idea what works and what not. And that is something that is sometimes useful.
You believe in pencil, paper, and an idea that can change the future. What does this mean for you?
I believe in order to really have even a scientific breakthrough, you need to have three ingredients. You need to have a valid experiment, so you have seen it in the real world. You need to have a kind of a simulation, so from first principles, or at least second principles, I'm able to derive what's going to happen. And then you need to understand roughly what's happening there. And that is the pencil and paper part. So in order to understand a technology really, I find it very useful in a way to free my mind from all the clutter of different images and of large tables, but to try to boil it down to the very essence. Because if you have understood a technology to the very essence, then you are able to derive from that how far you can drive the technology in principle. And then, of course, comes real life. What can be done actually? Do we have the technologies for this? But to have, first of all, the guidelines. What is possible with this technology? That helps a lot. And that can be really done with pencil and paper. It has maybe some connection to meditation, but I mean, it's really just working on the old-fashioned style. If you write something down, it's different than when you write code for a simulation. It's really a completely different approach to science, and I love this old-fashioned approach, I must admit, very much.
Let's move back in time a little bit and find out how Professor Michael Totzeck became the person he is. What did you think of yourself as a pupil in the 1970s, as a university student at the Technical University Berlin in the 1980s, and at 2002, when you joined Zeiss as principal scientist?
What did I think of myself? I think as a pupil, I was just a very ordinary pupil, medium in school until the onset of the 10th grade, 10th class. Then things became very interesting for me because then really science started. And I always wanted to become a chemist, by the way. I asked my chemist teacher, what do I have to do or to take courses in school still to really have a head start in chemistry? She said, yeah, it's not chemistry, it's physics and mathematics, because chemists usually, if they have issues, it's in physics and mathematics. So I started with these two courses, and fortunately for chemistry, I don't know. At least physics was so extremely interesting that then I moved to physics. So at the university, being a physics student, you work. I worked and tried to understand the science. So it was just really a complete student, focusing a lot on the field in order to get a grip on it, to learn the mathematics behind it, to learn the physics behind it. And my target was undefined, I must say. So in physics, I had the impression of something like everything is possible. You don't have to decide really right now. And so I moved on at the university. And then when I moved from Berlin to the University of Stuttgart in 1995, then there was at the Institute of Technical Optics, Professor Tiziani, he had strong connections to industry. And that was honestly my first real connection to industry. So to learn about all the different issues that they have then. And I was very happy to learn that there is really a very good application for science, and that you are able to bring your developments finally into industry. And out of these cooperations came my move to Zeiss, where I clearly wanted to bring progress in a way. Steve Jobs once said, so it's our task is somewhat like this. Our task is to make a dent in the universe. Why else should we be here? So, and I think and believe it is necessary to do something that is a difference when you die. So that really, I want to have done something that helped people so much that, again, it is a difference that whether I have been here or not have been here. And I think in an industrial context, in this industrial context at Zeiss, where I'm currently in, that is really the perfect environment for exactly this. And what I now try is, as you said in the very beginning, to bring forward here innovation. Innovation is speeding up and speeding up. So it's more and more important to really have some guidelines through all these innovation topics that we have currently. I consider it a huge privilege to live in these times, where really science and technology is developing at such a pace, and we are trying we are going to understand a lot of things that have been complete mysteries in the past, in the universe, and now even in our own brain, and of course still in optics and data sciences, for instance. So honestly, I enjoy this very much.
I think at Zeiss I read, quote, technological progress is running fast. Research needs to be running faster.
Yes,
unquote.
exactly.
So that's
To
your
stay ahead.
idea
Yes.
that you just mentioned. Yeah. So how can this be realized best? With the right team, with the right people, with so when I listen to you, I have the impression that you are a person who's looking for challenges and who likes to be challenged. How do you yourself challenge your team members?
That is not too difficult. So if you are in technology development and in the innovation management, there come ideas. And of course, these ideas are challenged at the very beginning. So we have a kind of a challenging culture, but it's really a challenge on, let's say, technical terms, on business terms. So is this technology really working? Does this technology have a market? Is this technology really wished by customers? So the main directions of the challenge are in the direction of design thinking. In design thinking, you have the topics of desirability, feasibility, and viability. And these three topics need to be fulfilled. And there we challenge and we discuss. But it is, you might have now got the impression that people come up by their own with a kind of an idea, then they bring it to the crowd, and then the crowd has some judgment about it. That is not the way how development is usually working. It's really more a collaborative process. So you come up with a weird idea. You discuss this weird idea, for instance, during lunch with someone from your department or someone else. You make a first small research of this weird idea, and okay, if you find out, hey, it's not interesting, then of course, stop it, done. But if it is interesting, you involve more and more people. So my job also as a team head is to bring the brains of the people to this topic so that they think as a group about it. Of course, you have still the scientist who's sitting behind his desk and her desk and is really, in a way, autark. But most often you develop ideas and concepts in workshop-like settings. That must not be really official workshops. It is more that you have an open discussion, but you have to really put down the ideas, you have to evaluate the ideas, and out of this you work ahead.
This is what happens at the company with among the scientists. There's also a lot of talk and discussion about how scientific results should be communicated to society, into society. Is there an approach that you favor in particular?
I don't think that there is the single approach. I love, for instance, I'm part of this podcast because I think the communication of science and technology is important for the society. I'm convinced we must have a lot of different approaches, so no single communication line, but really communication via audio stream like you do it, via videos, via journals, via short reports in the press and so on. So really a whole bunch of different communication concepts. But what is also very important from my point of view is that people are willing and able to receive this communication. So that's why I'm very happy that, again, in the Zeiss Foundation, who owns Zeiss, that there the education in science and technology is important, because this is also, you must understand the very basic concepts of science and technology, and that should be done in early ages. So what I dream of is a kind of a teaching and communication of science and technology starting from very early ages. And what would be marvelous if this does not depend on the income of the parents, but that you really have this right to learn for every child. That would be something that would be really great, and but would require that we put a lot more effort in this.
I would like to end our fascinating conversation about the work at the company like Zeiss and also your experiences, both from the academic world, but then also that you took to the company, and bring it back, of course, to the advisory board as well, by asking you 7 questions that we always ask our guests in our podcast. We call it Moment 7. We have collected Questions that we would like you to answer as shortly as possible. Moment 1. Spätzle or Maultaschen?
Clearly Maultaschen. I love the reasoning for this thing, for this meal.
Moment 2. One thing you could change about the world would be?
If it is, let's say, in a godlike manner, I would reduce the aggressiveness of the human beings in order to get it a little bit more peaceful. The other one would be, if I'm allowed for a second one, exactly this, have an education, a free, high-quality education for every child on this world.
Moment 3. Do you have a media recommendation for us? A book, a music style that you like, or an artist, a movie?
So what I do very often is I'm a fan of audiobooks. Two books recently come here to my mind. One is How We Learn from Stanislas Dehaene or so. I'm not sure how to pronounce him. That is absolutely cool about the science of education and our brain. And the other one is, if you really want to understand how semiconductor technology currently is working and what are the reasons for the situation we are currently in, that is Chip War by Chris Miller. That is an absolute fascinating book explaining how semiconductor technology has developed over the time of the Cold War, now even to the conflict between the US and China.
Moment 4. The best advice that you have ever received was?
That's a difficult one. I think a former boss of mine said, if you can't do it, delegate. So really make use of the people. So what is it? Incorporate different people in your tasks. Don't try to do it for yourself, but do it really in a team. For me, that was a learning experience because coming out of university, I was still in this single scientist models, and I learned over the time that it is much more efficient to do it in a huge team.
Moment 5. Your favorite place in the city of Stuttgart?
Currently, in the past, it was the rail station. Currently, unfortunately, it is definitely not the rail station.
Moment 6. If I could start all over again, I would like to do the following differently.
I would start to become international much, much earlier. So even as a student, I was a kind of very single-minded in my studies. And I didn't recognize at that time, hey, you have to do internships at companies, you have to be abroad in order to learn different cultures. I did this only after my change to Zeiss. I should have done this, honestly, much, much earlier.
And moment 7. Also, please complete this sentence. Thanks to my studies, I know that
science will never be over. So that seems to be, knowledge is a very large word here, Hybrid. There seems to be an infinite amount of knowledge, of possible knowledge in this world. So the story of science and education and innovation is not going to end in any foreseeable time.
Professor, thank you very much for your insights, for your recommendations, also for your contribution to the work here at our university. It has been a pleasure talking to you, and Professor Totzeck, we wish you all the very best for your work at Zeiss in the future with your team and also in the cooperation with the University of Stuttgart.
So thank you very much. It was my pleasure to be here. It was really just fun. Thank you.
and to our audience. Please stay tuned for our upcoming conversations that are always based on what is made in science. My name is Wolfgang Holtkamp. Have a great podcasting day. Goodbye and good talking.